Alright, so this is Math 152, assignment A, question 6, the last question in this assignment. So we're given a resistor network, which looks like this. There you go. That's what it looks like. And we're told that there's current of I here. We're told that this is 4 ohms. This is 1 ohm. This is 3 ohms. And we are given I, and we are given V. Now, we're not actually given these numbers, but we're told that they're given. And question A says, express the current through the voltage source. So current here, so I'm going to label as X. And the voltage across the current source. So here, so this is plus minus. Call this Y. In terms of arbitrary values of the sources, V and I. So we need to relate X and Y to V and I. So root for resistor networks, always start with current loops. There we go. So those are our currents. And from the first loop, that says loop, by the way. It might not look like it, but it says loop. So from the first loop, now a quicker way of doing this is like without showing the brackets, going straight to the simplified version. We start with I1, add up the resistances of all of the things that it goes through, so 3 and 1. Then I'm going to subtract all the currents in every other loop connected to it. And the coefficient is going to be the sum of all the resistances it touches. So here I2 only touches 1. The 1 ohm resistor here. That is in this loop. So it's just going to be minus I2. Equals, and this equals the voltage drop across here. Because the voltage in a closed loop has to equal 0. There we go. Second loop. Apply the same thing. The sum of the resistors is 5. And the only resistor that I1 touches, which is connected to the loop of I2, is the 1 ohm resistor. So this is minus I1 equals. And now you have to be careful with the directionals of which you pick. The answer here is actually negative Y. Now this is because as I2 goes around, the sum here is describing the voltage drops. So it drops here, but if I2 continues going around, you see that since the current source is pointing the other way, you have a current drop. You have a voltage drop in the direction of I2. So it should actually be plus Y. So it should be 5I2 minus I1 plus Y to get all the voltage drops. But since it's going to be equal 0, you can just bring the Y over here and get negative Y. So if you have your current going around and it goes into the plus side of the current source and comes out the negative side, then you have negative Y on this side. The next two equations on the bottom are just identity equations. I2 equals, obviously, since I is pointing up, this is going to be negative I. And we have I1. And I1 is going to be the current across the voltage source. So I1 equals X. So what we're going to do now is we're going to take these, and we're going to plug them into the top two equations. So I1 is just X, we get 4X. And I2 is negative I, so minus negative I is plus I, equals V. Just going to further simplify this to V to X, X equals V minus I over 4. There. And down here, we're just going to plug in the answers again. We'll plug in these two equations into here. And that gives us, since I2 is negative I, we can negative 5I minus x equals negative y. Now we can just cancel out the y's. Now we have x up here in terms of v and I, so we can just plug that in to give us 5I plus v over 4 minus I over 4 equals y. Now 5 is 20 over 4 minus quarter I plus a quarter v equals y. So we end up getting y equals 19/4 I plus a quarter v. So equations here, and I'm just going to write the x equation again. Those are our equations for V, for the voltage across the current source and the current across the voltage source, related to arbitrary values of I and V. So now B here. Now B just asks you to solve for two values of V and I. When V is 23 volts, I is 1 amp. So all we really got to do is, plug in these values. So y is going to equal 19 over 4 plus 23 over 4, which is 42 over 4. X is just going to be, 22 over 4. So X is 22 over 4 amps, because X, if you look up at a diagram here, is the current across the voltage source. So this is 22 over 4 amps, and which means Y is 42 over 4 volts. There we go. 6 is arguably the most straightforward and simple question on this entire homework, because it didn't even involve matrices. And if some people have felt the need to use matrices and use them, the question just says express the current in terms of the current and the voltage in terms of arbitrary values of V and I. So for the first question, we didn't need any matrices. We did what the question asked. Then the second part of the question, it literally just wanted you to plug in the numbers. It just said calculate the current source. What would be the point of you doing A if it wasn't to use in B? So you don't actually need matrices for this problem, and I don't think they meant you to use matrices in this problem. I think it's just a reminder, of here's how to do loops and stuff. Make sure you know how to do it. The next homework problem is probably going to have those kind of resistor matrices problems that we saw in class. So that's how to do question 6.